There's a claim that chewing gum stays in your stomach for 7 years after you swallow it. Well, I'm going to test that claim today by simulating the conditions of the stomach. First, I'm going to start with water at 37 degrees, which is body temperature. I'm going to simulate the stirring conditions, the churning of the stomach, by using one of these stirrers. And it makes it continually turn. Now, whilst the stomach is acidic, it's not strongly acidic. So I've got 1 molar hydrochloric acid here, but I need to dilute that down to 0.1 molar. So dilute it to 10%. I've got 200 mils here, so I'm going to add 20 mils of acid. Now we just need to add some amylase. Now this is amylase here, and amylase is an enzyme that breaks down starch. Now I'm going to add 10 mils of amylase to each one. Right, now all we need is some chewing gum. I'm going to try the pellet chewing gum, the ones that's got the sugar coating on the outside. So I'm going to start by doing some chewing, because of course the mouth is where digestion starts. Here's my chewing gum when it's first starting. I want to see if it breaks up or whether it stays like this. So I'm going to try another piece of gum. I've set up exactly the same conditions. This is that more softer gum this time that doesn't have that hard sugar coating on the outside. So I've been chewing this for a minute. Now I'm going to stick this into the other beaker. There's really 2 types of digestion. There's mechanical digestion and chemical digestion. Mechanical digestion occurs from the tongue and the teeth, chewing up the food. Chemical digestion starts with these things called salivary glands. Of course, they produce saliva, and in the saliva is enzymes. Enzymes are like chemical scissors. They chop up and break down the food particles into smaller particles. There's a particular type of enzyme that we're using called amylase. Amylase is an enzyme that breaks down starch, carbohydrate starch, into simple sugars. And that starts in the mouth. The salivary glands secrete saliva and enzyme into the mouth, and it mixes with the food as it's being chewed. Then of course the next stage of the process is that the food gets swallowed and goes down through the esophagus. And that's basically just a tube that takes the food down from the mouth or the oral cavity down into the stomach. Food generally spends about 4 hours in the stomach, and the stomach is a muscular bag that churns the food. So we have more mechanical digestion occurring in the stomach. As well as that, we have chemical digestion occurring in the stomach, because the stomach has hydrochloric acid, and that contributes to chemical digestion. Also, we have a temperature inside the body of around about 37.3 degrees Celsius. Now that temperature being really quite warm also speeds up the rate of digestion, simply because of the particle model, which says that particles are always moving, and particles move faster at higher temperatures. When particles are moving faster, they can collide more, and chemical reactions occur at a faster rate. So, does gum stay in the stomach for 7 years? In our experiment today, we've seen that in less than an hour, the pellet gum has almost totally broken up. So it's very, very unlikely that would have stayed in the stomach for 7 years. Now, the other gum really hasn't broken down too much. I could continue the experiment for longer, but we can see that it hasn't been digested anywhere near as quick. Does that mean it stays in the stomach for 7 years? So the science of chewing gum is that it's made with something called gum base. Now, often the gum base apparently can't be digested. However, it doesn't stay in the stomach for 7 years. It gets passed through as waste. However, in my experiment, I've actually seen that the gum base, for certainly some of the gum products, does break down in conditions that simulate a stomach.